Now this is an interesting chapter. It will answer a lot of your questions regarding our planet Earth. One of the biggest questions you should have in your mind is that why is the Earth the way it is? I mean, why is it uneven? Why is the surface of the Earth not smooth? Why there is elevation, then depression, upland and lowland? This should be the question in your mind right now. Because every day we walk on the surface, but we rarely have a doubt about why and how. Not everything is done by humans. I mean, there are places which are naturally elevated to give it a scenic beauty, but apart from that, entire surface of the earth is uneven. So in this chapter, we are going to learn about geomorphic processes. Let me first tell you the meaning of the word geomorphic. Let's break the word. So we have geo here and then we have morphic. Geo is basically earth. That's why geography is the study of earth and morphic means shape or form. So geomorphic means how was the earth formed or how did the earth get this shape. You see, there are two kinds of forces that acts on earth and it is constantly making it change. One is endogenic forces and the other is exogenic forces. One is internal and the other is external. I've made a video on this topic. The link is there in the description. Please do check it out. So this entire chapter is around this phenomena. I wish I could say we are done with the chapter, but let's just go ahead and finish this chapter. There's a question here that says, is it essential to distinguish geomorphic agent and geomorphic processes? Well, they are almost the same. I mean, the Earth's surface goes through both chemical as well as physical changes. Now, running water, groundwater, glaciers, wind, waves, and currents, etc., are exogenic forces. They act on the Earth's surface from outside, and they do both physical as well as chemical changes to the Earth's surface. But there's a process involved. It's not that quick that you and I can notice it instantly. It takes a while, and that's what the whole process definition is all about. I've made a video on how rocks turn into soil. You can see the process. It's like a step-by-step change that happens, and that's where this word process got associated as geomorphic processes. And when we see the term geomorphic agents, agents are like catalyst that is required for a change or a process to take place, without which the process is incomplete. So I hope you understood the difference between geomorphic process and geomorphic agents. They're just the same unless specified separately. Now we are going to read about endogenic processes. We have read about the meaning of this term endogenic. Endo means internal or inside. So these are the processes that takes place within the Earth's interior. So there's only one substance that's inside the Earth's interior, which has massive energy to cause all sorts of changes to the Earth's surface. And that is this hot molten material, which is known as magma. All sorts of big massive physiographic changes occur due to the movement and the heat generated by magma. Always remember this point. Now you will hear these two terms, diastrophism and volcanism. And we'll read about this going forward, but let me quickly tell you the meaning of the term diastrophism. It means a process that creates new landforms. So how are mountains created? When two crust plates come closer, the smaller one goes under the bigger plate, and that's how a portion of land gets elevated. Himalaya is a perfect example for that. So this entire process of making plain simple landform into folds, upland and lowland is called as diastrophism. We will read more about this. Now this point here is very important. The action of endogenic forces are not uniform. What it means is, if you look at the thickness of the crust, which includes both oceanic as well as continents, the thickness varies from place to place. It is not same everywhere. At some parts the thickness will be very less. In those specific parts, the chances of this molten material, which is magma, to come out of the crust is more likely to happen. And it is this magma which is responsible for both breaking as well as forming new land surface. So always remember the action of endogenic forces are not uniform. And just for the sake of argument, if it was uniform, then whatever that happened in the movie 2012 would get real. Everything would be destroyed. Now we're going to read in depth about the term diastrophism. The textbook definition says, all processes that move, elevate or build up portions of the Earth's crust come under diastrophism. Now I want you to recollect what we have read in chapter 3 of class 11, that is interior of Earth. In that we clearly understood that the crust is divided in the form of some major and minor plates. And these plates have three types of motions. When two plates come towards each other, we call that as convergent boundary. When they move apart from each other, we call that as divergent boundary. And then sometimes these plates slide past each other. So it is because of these three movements you will see changes on surface of the Earth, that is the crust. Now mountains emerge because of this. Then we have faults, huge cracks on the land surface because of this. So this is what is diastrophism. Now diastrophism is broadly classified into two types, that is epeirogenic movement and orogenic movement. The first one is epeirogenic movement. The word epeirogenic, let's break the word. The meaning of the word epeiros is land and genic can be derived from genesis, which means birth or origin. So together epeirogenic means the origin of land. Epeirogenic movements are vertical. So to make a piece of land, all the materials comes out from within the earth's mantle, that is the magma. When that solidifies, it becomes hard rock, and once rock begins to break down through weathering, it turns into sediments, and that becomes land for us. So the movement is vertical. Now what happens in orogenic movements is that orogeny is the origin of mountains. So their movements are sideways or horizontal movement. Now what happens when crustal plates move horizontally? They either come closer or they move apart or they slide past each other. But then in this we know it's a mountain forming process. And mountains are only possible if two crustal plates come closer. When two plates come closer, the smaller plate goes under the bigger one. That causes larger piece of rocks to twist and fold, making the land surface to elevate. And that forms a mountain. Now let me show few places of earth where this kind of mountain building processes took place. You'll find long mountain ranges in all these places. Here we have the Andes, then here is Himalayas, then here is Ural Mountains. This part is known as Rocky Mountains of Western United States. So always remember orogenic is a mountain building movement and epeirogenic is a land forming movement. Now the next topic is volcanism. So basically it means how the molten magma comes out on the earth's surface, and due to that many volcanic forms takes place. I've made a separate video on different types of volcanoes. The link is in the description. You can check it out. With that, we now move on to the next topic, exogenic processes. I've told you the meaning of the word exogenic. Exo means external. So these include forces that acts on Earth's surface from outside. Now outside there is atmosphere and of course the sun, which is the ultimate source of energy. Sun heats up the land surface, and heating up also creates some changes, which we will read further. An atmosphere is responsible for wind, rain, ice, etc. Apart from sun and atmosphere, there is one more element involved in the creation of exogenic processes, and that is the gradients created by tectonic factors. By gradients we mean an inclined land portion. Mountains, plateau, valleys, these are gradients. They have slope, ups and downs. So these are gradients, and we also know how these landforms are created. It is due to tectonic activities. Remember that part where I said the crust is divided into some major and minor plates, and movement of these plates is called tectonic activity. So it is due to that mountains and other gradients are formed. So overall, the elements of exogenic processes are atmosphere, sun and tectonic factors. Another important point that you will see here is that gravitational force acts upon all earth material. Gravity is something that is keeping everything, including us, in contact with the earth's surface. There is no doubt about that, you know that, right? However, the critical point to understand here is that in a slope area, that is mountains and other upland areas, here due to gravity, the movement of many big and small rocks takes place. Now this is also something that you know it, standard physics. Probably you have also seen it. What's interesting in this is because of this downward force, stress is produced in these rocks. And stress in solid is created by only pulling or pushing. So here gravity is doing that. I hope you're understanding it. Because of this force, the shape of the rocks slowly changes or deforms. There's a term given to it, deformation. So gravity is producing stress, and the stress is what is breaking rocks and other earth materials. Quite fascinating, isn't it? I mean, we know rocks break, but the method behind that, when explained in a step-by-step reasoning manner, it sounds nothing less than a story. Now beside the gravitational stress, there is another stress that occurs in earth materials. It is called molecular stress. In the previous chapter we have read that a rock is a combination of tiny crystal particles that are cemented together. And if we go into the molecular level to see it, you'll see small tiny chunks of soil debris of the shape of atoms. They are packed together, and this is applicable in everything that we see around us. All the objects, materials, everything has molecules packed together in various forms and shape. So when stress builds up in between these molecules, they start to split. In other words, loosening of bonds between the grains. Now when these molecules split, the result can be seen all the way to the big rock cracking apart, and that leads to weathering, mass movements, erosion. I hope you're understanding what I'm saying. So far we have read about gravitational stress, molecular stress, then temperature and precipitation and tectonic factors. So these are the exogenic forces that is constantly weathering or wearing and tearing down the Earth's surface. And not every place on Earth is facing these forces in equal manner. It is working in different speed and different manner because there are different climatic regions on the Earth. So if you see, exogenic processes are largely dependent on temperature and precipitation. And these two are directly dependent on climate. And climate changes from place to place based on latitude. As we move away from the equator, climate turns from warm to cold. And because of that, we see various direct and indirect changes. Look at this question. What is the sole driving force behind all the exogenic processes? The answer is kind of arguable. Moments back we read that it is because of climate. Climate differs from place to place, and that's what causes the change in temperature, wind velocities and directions. But then if you think a little more and understand, change in climate is again dependent on sun, because sun is the ultimate source of energy. So sun is the driving force behind all the exogenic processes. Remember that. Another important thing that you have to understand is that factors like climate, sun, gravity, molecular stress, tectonic movement, these makes the exogenic processes happen. Now this is one part of the question, we know this. We now understand it. The second part is, which I believe is equally important, and that is exogenic geomorphic processes depend upon type and structure of rocks. Now you would say that, what do you mean? Rocks are rocks. They are meant to be weathered. So why give importance to rocks? Well, we have to consider this aspect as well because rocks are of different types and structure. And because of that, a particular rock may be resistant to one process and non-resistant to another. For example, some rocks weather quickly with the help of wind, and then there are some rocks that weather quickly with the help of water. And again, due to this difference in weathering, the shape and structure of the rocks are uneven. They are not same. And finally, this gives rise to differences in topography. That's why some mountains are rough, edgy and tall. Then some are flat, smooth and not so tall. And this all takes time. It does not happen in fortnight. That's why the process is unnoticeable. If you can recollect, then I have told you previously that endogenic forces affects the Earth's crust from inside. Now we just read how the outside forces changes the topography. This all brings down to one fact that Earth goes through tremendous changes in some form or the other. Now we'll talk about weathering. So weathering is an action caused by climate or weather on the Earth's material. And it all goes through a number of processes. And we have read about those processes. So that's how it breaks the rocks into small fragments. Now weathering is of three types. They are chemical weathering, physical weathering, and then there is biological weathering. Let's read about each one of them. The first one is chemical weathering processes. By the term you can figure out that there is some chemical change that takes place in this form of weathering. Now what are those chemical changes? Rocks go through solution, carbonation, hydration, oxidation and reduction processes before it gets decomposed. For any chemical reaction to take place and speed up, we need water, air and heat. And these three elements are present in the atmosphere. That's why rocks go through intense chemical changes. We will quickly go through these individual chemical changes so that you can understand it better and what it feels like to be a rock. The first chemical change is solution. Anything that dissolves in water or acids becomes a solution. It removes the solid part of the rock by dissolving its minerals. It basically split or disintegrates. Rocks contain minerals like nitrates, sulfates and potassium, and these dissolves in water during rainy climate. Minerals like calcium carbonate separates from limestone, then salt, or as we call it, sodium chloride. It separates from rocks through the process of solution. The second chemical change is carbonation. Now carbonation is the reaction of a carbonate and bicarbonate with rock minerals. Carbon dioxide from the atmosphere and air is absorbed by water to form carbonic acid that acts as a weak acid, which removes minerals from rocks. That's the effect of carbonation. Then third chemical change is hydration. Hydration is the chemical addition of water. During rain, rock minerals take up water and expand. This expansion causes an increase in the volume of the rock material. And we have read how over time, due to expansion, rock split or disintegrates because the minerals in the rock continuously contract and expand during wet and dry climate. And it is this repetition that results in cracking of the upper rock material. Always remember, hydration is the addition of water, and water does a lot to a rock that we can never imagine. And the last chemical change is oxidation and reduction. Oxidation means a combination of a mineral with oxygen to form oxides or hydroxides, and reduction is where oxygen is absent. Oxidation occurs where there is a ready access to the atmosphere and oxygenated waters. And again, rain gives water and oxygen is obtained from atmosphere. So when it rains, rock gets wet and the rock minerals get disturbed due to addition of oxygen because water has oxygen element in it. And then reduction occurs due to absence of oxygen. Such a condition can be found under the water table. As you go deeper in sea, due to lack of oxygen, scuba divers carry an oxygen cylinder, and that is where reduction takes place. And there are many rocks below the table that goes through this kind of reduction. Otherwise, the rocks that are above in the surface face oxidation due to rain. So these were the chemical changes that a rock goes through. Now we will read about physical weathering processes. Physical weathering is also called as mechanical weathering. And this process is dependent on some applied forces like gravitational forces, then expansion forces due to temperature changes, and finally water pressure. Most of the physical weathering processes are caused by thermal expansion and pressure release. Always remember these two terms, thermal expansion and pressure release. Now we'll go through some different types of weathering that comes under physical weathering. The first one is unloading and expansion. When you look at a huge chunk of rock, probably of the size of a small mountain, you will notice that on top of it there will be a layer of rock or some soil. This layer faces continuous erosion because it is exposed to water from rain as well as wind activity, and it gets eroded or removed with time. However, you must understand that this top layer creates pressure on the underlying rock, and due to that the underlying rock gets fractured into sheets which lie perpendicular to the direction in which pressure is released. And if you look at this picture, you can see how the top layer cracks and breaks into sheets of rocks. The second one is temperature changes and expansion. When we say temperature changes, we mean heating and cooling. Now with rise in temperature, that is when a rock is exposed to sunlight, the temperature of the rock will increase and the rock itself will expand a little. Because every mineral in a rock expands and pushes against its neighbor, and as the temperature falls, that is after the sun sets, the rock cools down and contracts back down to its original size. Now this continuous movement makes the rock weak due to continuous fatigue, because over a long period of time this can actually cause the molecules that make up the rock to decay and causes cracks in the rock structure. And then not to forget, water can get into those cracks and speed up the process of splitting. The third type of weathering in physical weathering is freezing, thawing and frost wedging. Frost wedging is a type of mechanical weathering caused by frost and ice. Water expands when it freezes, and repeated cycles of freezing and melting slowly weakens the structural integrity of porous and cracked rocks. This process is most effective at high elevations in mid-latitudes, where freezing and melting is often repeated. We have also read that as we move away from the equator, the temperature falls. So mid-latitudes areas are ideal, because here freezing as well as melting both occurs compared to areas where there is only ice and glacier. And the fourth type of weathering is salt weathering. Now always remember this, salts in rock expand due to thermal action, that is heat, and also due to hydration and crystallization, that is when it comes in contact with water. Rock contains variety of salts like calcium, sodium, magnesium, potassium and barium. They are usually found in granite. These all salts have the tendency to expand. So if the rock is in the desert, then due to high temperature of the sun rays, the salts in the rock will expand and push the walls of the rock. It will eventually make the pores of the rock bigger, and finally the rock will split. So here's an example of salt weathering of granite at the French Mediterranean coast. So you can see how the granite rocks are disintegrating. Here both the water from the sea and the heat from the sun is acting on the rocks and making the salt weathering process work fast. So these were all the various weathering processes under physical weathering. Now let's read about biological activity and weathering. We have often heard that organisms like earthworms, then termite, rodent, algae, then decaying plant and animal, these all helps in mixing air and water with soil to make it fertile, which is good for agriculture and irrigation. In fact, even human beings by plowing and cultivating soils, they are in a way mixing and creating contact between air, water and minerals in the earth materials. And in this chapter we have also seen how plants like mosses and lichens slowly breaks a rock into pieces because growing plant roots can exert pressure on rock. So this is what is the meaning of biological weathering. Here are some biological elements, or I can also call them living organisms, some of which we cannot even see with our eyes. They are slowly making rocks weak and turning them into soil. And it is very fascinating to actually know about such minute changes that occurs in our environment, about which rarely people have any idea about. Now we will read about some special effects of weathering. Moments back we have read various types of weathering processes under physical weathering section, especially the topic unloading and expansion. There we read how the top layer of a big rock creates pressure on the underlying rock, which then leads to disintegration of the above layer in sheets. So this is a special effect because this is a result of a certain process. So we understand what weathering is. We also understand what are the elements and conditions that is required for weathering to take place. Along the way, there will be some effects. So they are natural effects. That is what we mean by special effects. So unloading and expansion is a special effect. And it is fascinating to see how such an effect takes place. Though it is a slow process, but it is quite fascinating. Now we go to the topic significance of weathering, meaning what is the importance of weathering. This topic might be useful for writing essay or answering critical questions related to geomorphic processes. To answer this question, first try and answer what is weathering. It is a process that breaks down the rocks into small fragments called as grains or soil debris. In other words, when a rock gets weathered, soil is formed. Now the next question should be, what is the use of soil? So forest, that is natural vegetation, is largely dependent on soil. Without soil, how can a tree or a plant grow? So forest is dependent on soil and its quality. If rocks don't weather and if there is no soil erosion, then how will places get trees and plants? Which is very essential for the development of our biomes and biodiversity. Another point is that rocks contain different kinds of mineral, which are packed together. After weathering, these mineral grains get transferred to soil, and then due to erosion, soil gets transported from one place to another. If this natural mechanism doesn't exist, then how will there be large deposits of valuable ores of iron, manganese, aluminium, copper, etc.? These minerals are important for the national economy. So you see how weathering is important from environmental as well as economical point of view. Now we will read about mass movements. These mass movements transfer the mass of rock debris down the slopes under the direct influence of gravity. That means no geomorphic agent like running water, glacier, wind, waves and currents participate in the process of mass movements. Mass movement is of two types, slow and rapid movement. If you look at this small clip, you can see a landslide wherein the earth materials like rock, soil debris are moving downwards due to pull of gravity. There are several reasons behind such mass movement, and we'll read about them. So the first one is removal of support from below to materials above through natural or artificial means. There must be some rock or a layer of soil that was holding up or supporting the big massive earth material. As a result of its removal, everything comes trickling down. The second reason is increased gradient and height of slopes. Naturally, if the height of a landform increases, the more steeper it becomes. That will eventually let the earth material fall off, just like how we saw in the landslide video. The third reason is occurrence of earthquakes, explosions or machinery. Now earthquake is also a reason wherein the shock vibration travels through the earth material, making it unstable. Explosion and machinery are artificial ways of inducing that vibration. The fourth reason is indiscrimination removal of natural vegetation. In other words, we can also call it as deforestation. Tree roots hold the soil together and helps to prevent it from flowing away due to water or wind activities. Now, removal of trees will accelerate the process that will cause massive soil erosion. The fifth reason is heavy drawdown of water from lakes, reservoirs, and rivers, leading to slow outflow of water from under the slopes of river banks. Now, flowing of water will lead to gully formation. Continuous pouring of rainwater will cause gully formation on these slopes, which will eventually cause soil erosion. So these are some of the ways that activates mass movement, or in other words, a landslide. So mass movements can be grouped under three major classes: slow movements, rapid movements, and landslide. Let's read a little about slow movements. By the name you can understand that the movement of earth materials is going to be very slow. That goes on for years or even centuries. One such movement under slow movement is called as creep. Creep is a very slow mass movement. We cannot see creep happening, it is that much slow. You must have seen fence posts or telephone poles lean down slope from their vertical position. Now it is because of creep effect. You are also aware of terrace formation. Some hills are covered with long narrow steps. They are built by soil creep. Very slowly the earth material, that is soil and rock debris, comes downwards because of gravitational pull. And if you want to know more about creep effect at molecular level, then try to understand this. We know that soil particles expand and contract due to heat and water. Because of this repetition, each particle in a soil moves a millimeter to a few centimeter at a time. So this slow mass movement is called creep effect. Another such movement under slow mass movement is called as solifluction. It is a slow downhill flow of soil in Arctic regions. This process is quite common in moist temperate areas where water logging of sediments occur due to long continued rain or glacier formation. In this process, the upper portion of the soil gets saturated due to water and the lower part does not get any water. And then because of gravity and downslope, the top soil breaks from the down part and moves ahead. This process is called solifluction. Now we will read about rapid mass movements. By the name you can understand that the movement of earth materials is going to be rapidly fast. We have three types of rapid movements, and they are: the first one is earthflow. In this type of rapid mass movement, massive amounts of soil and rock material gets saturated with water and flows down the slope under the pull of gravity. Now the second one is mudflow. It is somewhat similar to earthflow, but then it is a little bigger in quantity. Now you have seen an example of mudflow on TV in the recent times. I'll tell you where. You must be aware of the natural disaster that occurred in Uttarakhand due to heavy rainfall. More importantly, you must be familiar with this scene where thick layers of soil and rock debris got saturated with water and rapidly came down from the hilly areas. This is an example of mudflow. They are highly destructive. In this case, you have witnessed how it damaged roads, houses, bridges, etc. Now the same action also occurs at volcanic regions. There also you have the conditions like high, steep, heavy rain and volcanic ash that takes the place of soil and rock debris. The third type under rapid movements is debris avalanche. They are similar to snow avalanche but occurs mostly in humid region, which is equatorial region. They also occur mostly in regions where there is less vegetation cover, because trees and plants holds up the soil together and lack of it will cause massive erosion. This debris avalanche can be much faster than the mud flow. That is, in a second, massive chunk of earth material can be displaced. The third class under mass movements is landslides. These are rapid movements and they strike in an instant. The earth materials involved are relatively dry, and landslides depends on the nature of discontinuities in the rock, the degree of weathering and the steepness of the slope. So based on this, there are certain types of landslides, and they are: the first one is slump. So what happens in this is, you see this piece of landform or mountain. This is the steep area. From here, when the earth material, that is soil and rock debris, when it breaks and slides downwards, this creates a curved surface. It's as if a scoop of mud has been taken. In a slump, this portion of the mountain moves only a short distance. If you look at this figure, you can see the initial position of the slope of this mountain, and after the occurrence of slump, there is curved surface and the earth material doesn't go very far. The second one is debris slide. A debris slide is a moving mass of loose mud, sand, soil, rock, water and air that travels down a slope under the influence of gravity. The moving material must be loose and capable of flow. Have a look at this clip and you can understand what is a debris slide. The third one is Rockslide. By the name you can figure out that a single large piece of rock gets detached and slides downwards, which is very fast and destructive. Have a look at this clip in which you can see a rock slide in Switzerland. So these were different types of landslides, and this constituted the third part of mass movements of earth materials. Now we're going to read about process of soil formation. I'm going to make this topic easier to understand, hence I'll show it to you with the help of illustration. So let's look at it. So what is the process of soil formation? There's another term given to it. It is called pedogenesis. The person who studies soil is called pedologist. Now when we think of soil, these are tiny debris or particles. And where do these particles come from? Now that's the first question in soil formation. It all starts with weathering of rocks. Weathering is an exogenic force. Rocks get weathered due to activities of wind, glaciers, rivers, rain, waves and currents. So these are agents that help in weathering rocks. But how does it happen? That's what we'll see now. So when it rains, water falls on the rocks and they sweep into the cracks of rocks and freezes. Frozen water expands and that exerts pressure on the walls of the rock. This pressure is enough to make the walls crack further apart, thus expanding and deepening the crack. This is what happens to the city roads and footpaths. That's how they crack. Another way rocks crack is due to the actions of plants and animals. Some plants like mosses and lichens are capable of growing without soil on bare rock. While growing, their roots penetrate into the rocks by creating pores, and when mosses and lichens grow into grasses and ferns, then it grows into later on bushes and trees. This causes rocks to split apart as the roots force their way down through the rocks. The same mechanism how water splits the rock. If you dig into the soil deep, at some point you will reach the bedrock. Now what animals do is they create holes in the soil by digging. That allows water to reach down to the bedrock, and same thing happens again. Water splits the rock. This is how rocks break down and soils are formed. Now we will read the last topic of this chapter, soil forming factors. There are 5 basic factors that controls the formation of soils, and these individual factors affect the action of one another. So let's read about each one of them. The first one is parent material. When we say parent material, actually we can also call it as parent rock. After all, soils are formed from weathering of rocks. And we have read it in earlier chapter, that is rocks and minerals. There we have seen how rocks are these tiny soil debris packed together. And these soil debris have crystals, which are minerals, and they have certain structure and texture. A rock's face continues weathering. Hence, soil formation very much depends upon what kind of rock it is and what sort of structure and texture it has. The second one is topography. Now, topography means terrain. Depending on the terrain, soil's thickness is determined. So if you look at a mountain or an elevated area, their erosion takes place very rapidly. There you will find soil cover to be very thin. Now this region goes through constant weathering due to wind and water. That's why the top portion of the mountains have this sharp pointy structure. Now soil cover is going to be thick in flat land areas because here the soil accumulates and forms layers over a long period of time. Also you'll notice in plain areas, soils will have more sticky property like a clay because water content is high in plain area and that helps in retaining moisture content in the soil, making it hard and intact. Now talking about latitudes. As we move away from the equator, temperature decreases. It gets colder. That also has an effect on the soil because equatorial region is a warmer region as sun rays falls directly. This warms up the soil and due to that we can see different forms of vegetation like tropical forest, deciduous forest. And as we go away from the equator, soils facing cooler temperature have some other form of vegetation on it. So topography does matter in determining the quality of soil. The third factor is climate. When we hear the word climate, 2 things come to our mind. One is moisture that comes from water in the form of rain or snow, basically precipitation. And the second thing is temperature. Is it warm, cold or moderate? Because temperature and moisture both are important factors in the formation of soil. And I'll tell you how. So water is responsible for downward transportation of soil components. Areas with high rainfall are a perfect example. Here, due to so much of rainwater, so rocks consist of silica in abundance. water removes silica from rock, and this is called as desilication. And during warm climates or high temperature, evaporation takes place. You know what evaporation is. It brings the groundwater to the surface by capillary action. And then water evaporates and leaves behind salt. And then those salt becomes hard crust, which are also known as hard pans. And you must have heard about this rock called kankad. Basically, it is calcium carbonate. So this rock is formed from hardening of salt residue. Water also activates bacteria and microbes in the soil to do their biological activity, making it fertile and all. So this is what the role of climate is in the formation of soil. And the fourth factor is biological activity. When we talk about biological activity, we are referring to the bacterial activity like decaying animal and plant materials. Dead plants provide humus, and it contains some organic acid that helps in decomposing the initial parent material. So look at it this way. Imagine a big piece of rock. Now it goes through weathering, water falls on it, wind rubs on it. Slowly plants like mosses and lichens starts to form on the rocks. They start to grow and their roots slowly penetrates into the rocks. Now due to that, rocks start to crack. Like this, rocks turns into smaller chunks of soil debris. And over the time, animals, plants, and then microorganisms, earthworms, etc. all these slowly starts to alter the chemical composition of the soil. And this changes the soil composition from what was a rock at some point to a now soil of different composition. This is the effect of biological activity. One more point is that bacterial activity differs in cold and warm climates. What I'm trying to say is, when the soil is cold and when the soil is warm, in both cases, bacterial activity will be different. In cold climates, bacterial growth is slow. Ever wondered why we keep some foods in the fridge? It is because cold temperature keeps microorganisms such as bacteria, mold, yeast from growing and harming the food. Now in tropical and equatorial climates, the bacterial growth and action is intense. That's why in summer, if you keep your food items out of fridge, it gets spoiled. Then nitrogen fixation is high in warmer region. Then animals like ants, termites, earthworms, rodents, they feed on soil and their movement makes the soil up and down, which changes the texture and chemistry of the soil. And the fifth factor is time. I think we all can agree that time is an important factor in creation of many stuff that we see around us. Here it says the length of time the soil forming processes operate determines maturation of soils and profile development. A soil becomes mature when all soil forming processes act for a sufficiently long time, developing a profile. Everything that we read in this chapter, from weathering, erosion, denudation, biological activity, fixing and mixing, everything needs time. And with this, we have come to an end of this chapter. The question answer can be found on the website. Make sure you check it out once after you have understood this video lecture. The link is in the description. Do check it out. Alright then, thanks for watching and I'll see you in the next one. If you want to see more of such educational content, make sure you're subscribed. By doing so, you'll get an alert when my next video comes. Thanks for watching and I'll see you in the next one.